Hello everybody, and welcome to the next video of the course. The topic of this video is conditional statements. This video has two goals. I would like to introduce to you Python's if, else if, else if, else structure. This allows a program to go down multiple distinct different paths. So you might have code you want executed sometimes but not other times. This structure will allow you to set up that kind of thing. Last time we also talked about different arithmetic operations you can do, so you can add, subtract, multiply, divide, etc. I just want to do one more operation that's similar to division, or at least related to division. It's the percentage operation. Okay, so to motivate the conditional statement material, suppose you're taking a class with homework, 2 in-semester exams, and a final exam, and those are all the components of the grade. So there's no quizzes or whatever, right? And suppose that the grading structure is set up like this. Homework overall is worth 30% of your grade. Each in-semester exam is worth 25%, and the final is worth 20%. So the first thing you might want to do is write a program that calculates your numeric final grade. And I have such a program written. And it looks like this. I have 4 variables for the 4 grade components: homework, exam 1, exam 2, final. I have given each of those variables a value. So maybe your homework grade is a 90, your 2 exam scores were 85 and 80, and your final exam score is a 92. Okay, given the percentages on the previous slide, given that homework overall is worth 30%, your exams are worth 25%, and your final is worth 20%. Sorry, there's a typo there, 20%. Okay, you can just calculate what your final grade is. So your final grade is the weighted average of those 4 variables, and then have the program print to the screen, your final grade is, and then tell you what your final grade is. So if I hit run on this, my final grade is an 86.65. Pretty good, right? So depending on how your professor grades, that's a B or a B+. Okay, so there's a program that does that. Okay, you might, though, not just want a numeric grade, you might want a letter grade or maybe a pass-fail. So let's start with pass-fail first. That's the simplest setup. So suppose you're taking the class pass-fail, which means you don't really care about your numeric grade, except that you want it to be 70% or higher. So now the question is, how could we teach the program what a pass means and what a fail means so that it could print pass or fail instead of the numeric grade, maybe? And the answer is conditional statements. So in the code itself, what do you need to be able to do? Bring it back up. So right here, I have calculated the final grade. Right there, you need to be able to tell Python, tell the computer that if this number here is a 70 or bigger, the student has passed. If not, though, right? Otherwise, if the grade is less than 70, the student has not passed. The student has failed. So the way you set up that kind of structure is like this. It's supposed to match the English as close as possible. If final grade is 70 or higher, so the way you have to do that in Python is greater than or equal to 70. So you can just read this like in English, right? If final grade is greater than or equal to 70, then you got to put a colon. Okay, so you set up a condition for the computer to check, right? The computer will ask itself at this point in the code if final grade is 70 or bigger, and if it is, the computer will now do whatever you tell it to do. So in this case, I'll write here print. This is what it means for a student to pass. And there you go. Notice a few things. You need this colon. Without that colon there, the code was mad at me, right? So it puts that little red X right there. Notice also that I have actually indented this code right here. So indenting means the computer knows, oh, this is part of this if structure, right? This command right here. So I'm only going to do this command if this if condition is satisfied. So this is sort of hierarchically underneath the if. So anyway, this is how you tell the computer if some condition is met, then please do something for me, like print a pass. Well, what if the student doesn't pass, right? Then you can do this catch-all command called an else. So if the final grade is literally anything that's not 70 or higher, you can tell it to print fail. Okay, so that's how you can set up an if-else structure here. So notice, what have I done? I've given the computer two separate paths it might go down. In one of those paths, it prints pass, and the other path, it prints fail. And notice, it's not going to do both, right? So I've given it two distinct paths to go down. So in this case, if I run this code, the first thing it tells me is that I passed, which is not surprising because my grade was an 86.65. But, you know, if I perform much worse, let's do 50s everywhere. So if these are my scores, the average is not going to be a 70 or higher. The average is going to be a 51.65 overall, and it tells me that I've failed. Okay, so again, what is Python doing? It just reads from top to bottom. So it sees these four commands, just puts those values in those variables. It does this calculation for you. And now that final grade has a value, and the value in this case is 51.65, but it changes based on these values. Once final grade has a value, the computer can evaluate whether that value is 70 or higher or not. Okay, the last note about this is that the word else, it's supposed to match the English, but a better English word might be otherwise. So the way you read this in English is, if final grade is 70 or higher, print pass. Otherwise, print fail. And you've given it two separate paths to go down. So that's how conditional statements work. Okay, so just a bit of syntax here. I used this command, greater than or equal to. There are other things you could ask it to check. You could ask it to check if something is less than or equal to, greater than or equal to, or actually just straight up equals. And notice there are two equal signs here. That is not a typo. If you are asking the computer to check a condition for you inside of an if statement, you need a double equals. Okay, so let's use that double equals in this program we have going. So suppose you want to write a program that prints pass or fail basically, but if a student gets exactly a 70, you want to print something else to them, like, ooh, you passed, but just barely, right? You just barely made it across the finish line. You could set up some structure like this. If final grade is 70, print barely passed. Okay, so that's how such a program might start. And so notice there are two equals here, right? So the computer is going to check if final grade is 70. So let me just make the final grade 70. So the easiest way to do that is to make all the grades 70. So now if I run this, right, your final grade is 70. Ooh, you barely passed. Okay. So all of that to say, right, the double equals is needed. So back up here, why do I not have a double equals? The answer is because I'm actually literally putting the value of 70 into this box in memory, this homework box. Here, though, I'm not telling the computer to put a value of 70 into final grade. Right? Why would I do that? I'm doing a check right here. I'm not doing some sort of assignment. I'm not assigning a value of 70 to final grade. Final grade got its value up here. So right here I'm checking whether or not the value in that box actually is a 70. So all of that to say, if you want to put a value into a variable, you use a regular equal sign. This is called an assignment equals. You are putting that value into that box. Here, though, anytime you want to check if something is equals, so if something is equals, you would use a double equals. This is called a Boolean equals. It's just to distinguish that you're checking a condition, not doing an assignment. Okay, so that previous program that I started to write, where if you barely pass, it'll tell you, there are other conditions you might want to have printed, like if you pass but comfortably, right? You might, like let's say that you pass with a score of an 85. You might want to have the computer tell you that you passed comfortably. Or you might want to have the computer tell you, oh, too bad you were taking a pass-fail because you would have gotten a B. Whatever. All I'm saying is when you set up this kind of structure, you might want more than two paths for your computer to go down. So the original program I wrote with an if 70 or bigger or else, there were only two paths for the code to go down. It could go down the pass path or the fail path. You may want more paths than that. And the way you set up that kind of structure is with an if, else, if structure. So you tell the computer, well, if something, then whatever, right? Then you can tell it, oh, otherwise if something else, right? Do something else, whatever. Otherwise if, otherwise if, otherwise. You can set up as many distinct paths in the code as you want. So let me just come back to the code and set that up. Okay, so if the final grade is 70, I could tell the computer to print barely pass. Otherwise if, else if, and Python abbreviates it like that, elif, but it's an abbreviation for else if. Else if final grade was bigger than 70, then you could have a print, just pass, whatever, right? And then the final else condition would still be fail. Right, so here's a program that will calculate your grade for you. If you just pass by the skin of your teeth, it'll tell you that. Otherwise, just pass or fail. So I didn't change the values here, so I still barely passed with a final grade of 70. If I change one of these scores to an 80, my final grade was a 72.5, so I just passed, not a barely pass. Okay, so what you should take away from this example is I have given the code 3 possible paths to go down. It can go down the 70 path, the bigger than 70 path, or the catch-all, whatever else happens path, which in this case means less than 70. Okay, but you can set up as many paths as you want to. The important thing to take away from this, though, is that each path you will go down at most once. You are giving the code a bunch of different paths sort of to choose from, but it can only choose one path. So it's not going to go down both this path and this path, for example. Okay. So think of a tree structure like this, right? You can go down the if path. If you don't go down that path, you can go down the first else if path. If not that path, then the next path, etc. So think about Python just marching through this hierarchy and seeing which path it could possibly go down. Okay, so the last thing I want to do with this example in particular is calculate sort of a more realistic grade program. Most students don't take things pass-fail. They want their A, B, C, whatever, right? So let's write a program here that actually outputs the letter grade. And the structure I want to use here is a 90 or above is an A, 80 or above is a B, etc. Between 80 and 90 is a B, etc. So we're not going to do it plus minuses, and the cutoffs for the grades are the multiples of 10. So 90 or above A, 80 to 90 B, etc. Okay, so let's get that structure going. So if the student gets a 90 or above, you should tell them they got an A. Otherwise, if the final grade is an 80 or above, they should get a B. Okay, so at this point, we should ask ourselves, what happens if final grade is a 92, for example, right? Well, 92 is bigger than or equal to 90, so you will print A. 92, though, is also bigger than or equal to 80. So you might think the program might also print a B, right? Because both of these conditions are satisfied. A 92 satisfies this, also satisfies this, okay? But notice that won't happen because of what I said previously. You are setting up a bunch of distinct paths. The code can only go down one path. Once it goes down a single path, it just skips all the rest. So if the code goes down this path, it just jumps right down to here in the code. It just ignores all the other possible paths because it's set up to only go down a single path. Okay, so now I can just continue this way, doing a C would be a 70 or above, where again, keeping track that I've already done 80, 90, right? So a 92 also satisfies this, but because you've already gone down the first path, you ignore these subsequent later paths. And finally a D would be a 60 or above. And if you didn't manage a D, then you failed. Okay, so this setup I've got so far, 70, 70, 80, 70, it should print a C off of that because my final grade is 72, and that is what it prints. Suppose that everything is in the 80s. Then it should print for me a B of some kind, right? Yeah, B, 82.65, etc. Okay, so here's how conditional statements in Python work. I have given the code, in this case, 5 distinct paths it could go down. It starts at the top. If it doesn't go down this path, then it skips it. If it doesn't go down this path, it skips. But then finally, if it does go down this path, it will do what you tell it to do. You told it to print a C. and then it would just ignore all the further ones. Okay, so to finish up this video, just one quick new operation that's in the same vein as plus, minus, times, whatever. It's just something you can do to two numbers. It's called the percentage operation, and it works like this. If A and B are whole numbers, then A percentage B is the remainder when you divide A by B. Okay, so if that's opaque to you, here are some examples. 7 percentage 2. What is that? Well, to answer that question, you have to divide 7 by 2 and figure out what the remainder is. Well, when you divide 7 by 2, the remainder is 1, okay, because 2 times 3 is 6, right? So 2 goes into 6, but then there's 1 left over. So when you try to divide 7 by 2, you get a remainder, right? 2 doesn't go into 7 evenly, and that remainder is 1. 3 does go into 6 evenly, so 6 percentage 3 is just 0 because there's no remainder when you divide 6 by 3. 9 percentage 5, right? 9 is not a multiple of 5. 5 doesn't go into 9 evenly. 5 goes into itself one time, right? So if you divide 9 by 5, you have 4 left over. That's how the percentage operation works. It tells you a remainder when you try to divide things. So it's related to the division operation, obviously, right? But the division algorithm, or the division operation, right, just tells you what that division is. So it would tell you 9 divided by 5 is 1.8 or whatever, right? 6 divided by 3 is 2. If you don't care about the division itself, though, necessarily, you just want to know how much is left over after performing the division, you would use this percentage symbol. So here's an observation that will be useful later in the course, because right now you might be thinking to yourself, who cares about this? You know, we'll use this operation later for more sophisticated programs. So here's just an observation that will be useful later. A percentage B is 0 if and only if, when you divide A by B, you get a remainder of 0, but that's just a quick way of saying that A is a multiple of B. Right? That's why 6 percentage 3 was 0, but 7 percentage 2 was not 0. 6 is a multiple of 3, 7 is not a multiple of 2. Okay, so let's just use this operation for a basic low-level program. Let's write a program that tells us whether or not a number is even, where what does it mean to be even, right? Even numbers are like 2, 4, 6, 8, etc. Even numbers are the multiples of 2. Okay, so to be even means A percentage 2 is 0. Right? 4 percentage 2 is 0. 6 percentage 2 is 0, etc. But 7 percentage 2 is not 0. So to check if a number is even, you can use this operation, right? Just take your number, percentage it 2, and see if you get 0 or not. That's how the program will go. So let me clear out all of this. So I have my number, and it's whatever it is, 9. And I could set up an if-else structure like this. If number percentage 2 is 0. Right, so I take my number, I divide by 2, I get a remainder of 0, meaning the number was a multiple of 2. Then I want to print your number is even or something. Otherwise, print your number is odd. So let's just run this. In this case, right, my number is 9. 9 is odd. 9 percentage 2 is not 0. 9 percentage 2 is 1. And it told me your number is odd. If I change it to an even number, like say 16, it tells me your number is even. Okay, so here's sort of a lower level, more trivial example of using this operation. We will be using it for more sophisticated things later. Okay, so at the end of this program, you should have some level of comfort with the if-else structure in Python, and you should understand how this percentage operation works.